Yeah, when we talk about sag tension in conductor design and also for line design, fundamentally there are three types of sags. One is from temperature, thermal sag. One is from creep. The conductor may creep because of especially the aluminum creeps. And the last part is about sag from ice, for example, ice or snow. And we have thermal sag, for example, really driven by knee point and also by the thermal expansion coefficient of the core material that we have covered that fairly extensively. The advanced conductor has an advantage because the composite material normally have substantially lower thermal expansion, so they don't have a thermal sag issue. In the creep, most of the time we talk about creep in the context of conductors like AAAC or AAC that you don't have a strength member. And this is actually something that our industry traditionally use ACSR methodology and thinking that you do creep based on a projected 10-year creep, from limited laboratory testing, like 1,000 hours. And when you have conductors that does not have strength member in it, you actually have creep going beyond 10th year because all you got is aluminum. They will continue to creep, and oftentimes we underestimate the creep-related sag for those type of conductors. And on the sag from ice and the snow, this is really driven by the tension in the conductor because we are adding snow and ice on it, in addition to conductor weight. If you have long span, you're going to have a lot of conductor weight to deal with. And if you have a lot of ice or snow built on the conductor, you also have a lot of tension in the conductor to deal with. So how much the conductor might sag because of weight. The weight is a combination of the conductor's weight plus the snow weight plus the snow and ice weight. It really depends on the modulus in the conductor, and especially the modulus in the composite core. And if you have a composite that has a lot of fiberglass in it, which TS does not, you have to be concerned about that low modulus, about the excessive sagging because of the weight-driven sag in these type of circumstances. So the perception about advanced conductor that they have a sag problem, these are associated with first generation advanced conductor that the modulus is relatively low, that they have a sag problem. TS conductor fundamentally is different. We do not use any fiberglass in our conductor design or configuration, and we have a very respectful modulus, and that allows us to be able to, one, deal with heavy ice, and it is also helpful that when you have low sag, that allows you to do longer span as well, and river crossing. We have done Mississippi river crossings, for example, because the conductor has a very decent modulus that allows you to manage the weight-driven sag.